Okay, our next and final problem is an integral involving partial fractions. So the way you recognize this usually doesn't tell you that it's a partial fraction problem. So the way you're going to have to recognize this is that you have something that's a polynomial over a polynomial. So I'm going to get rid of those, but you're going to look for something like that. Plus, you know, you're going to have to see I can't do a u sub here. So if we try a u sub, and maybe try to u sub at the bottom, it doesn't work. So if we can't do a u sub, we're going to need to do a partial fraction. So let's go ahead and look at this thing. So to do a partial fraction, what we do is think about this function as x squared plus 1. So first off, we're going to need partial fraction. You need two numbers multiplied in the bottom, or two polynomials. So we can see we can factor this a little bit, and we have this 5 minus x squared. And then we assume this is written as a over x, your first one. Now, this is a little tricky, a partial fraction rule. If we have an x squared for one of our terms, we have to assume it can be written as bx plus c over 5 minus x squared. So in general, you want the numerator 1 power lower than the denominator. Okay. So once we have this, really what we want to work with is this stuff. Okay, so we have this. So the way I like to do this is think about we multiply everything by the denominator. So we multiply everything by this. So we have x squared plus 1 on the left hand side, x times 5 minus x squared. Now that's going to cancel this and this and this and this. But then we multiply on this side as well, so we have a over x times x 5 minus x squared. And then we had plus bx plus c over 5 minus x squared times x times 5 minus x squared. And then we do this because we see some cancellation like we'd expect. We do this. So we get the system x squared plus 1 on the left hand side, right, is equal to a times 5 minus x squared plus bx plus c times x. Okay, let's expand this a little bit. So we have 5a minus ax squared plus bx squared plus cx. Now, I'm going to go ahead and put this on a new sheet. So really, this is what we have. X squared plus 1 is equal to 5a minus ax squared plus bx squared plus cx. Okay, so this might not be the way you're used to doing this, what I'm about to do, but this way always works. So I'm going to look at each terms. So I'm going to look at x squared terms. So what I'm going to do is make a table. On the left hand side, I have something, and then I have something else here on the right hand side. Okay, so my x squared terms, I have 1 on the left hand side, and I have equals minus a plus b. Right? Okay, Now, then I do x to the 1, and I have a big 0 here, right? I have no x to the 0. I can write this as x squared plus 0x plus 1 is equal to, right? And then here all I have is this c term. So I have 0 is equal to c. So now I know what c is. And then I have my x to the 0 terms. And on the left-hand side I have 1 because x to the 0 is equal to 1, right? So I have a 1. And then I have is equal to, on this side I have a 5a. And that's all. Okay, so now we know that c is equal to 0, a is equal to 1 over 5, and then the first equation tells us that b is equal to 1 plus a, which is equal to 6 over 5. Okay, so now we know what was our original function. Our original function was x squared plus 1 over 5x minus x cubed. So x squared plus 1 over 5x minus x cubed is equal to, well, we guessed it was equal to a over x plus bx plus c over 5 minus x squared. So we have 1 over 5 over x, right? This is a, plus bx, 6 over 5 times x, plus 0 over, and this one was 5 minus x squared. Okay. Or I can rewrite this as 1 over 5x plus 6 over 5 x over 5 minus x squared. Okay. So now, what's nice is now if we do this integral, which looked really hard at first, well, now we could just do 6/5 integral x over 5 minus x squared dx plus 1 over 5 integral 1 over x dx. Okay, so we know how to do this integral, right? This one we just write down. So we just write this down as 1 over 5 ln x. Now this other integral can be a little bit trickier. So for this integral, let's do u is equal to, let's try u is equal to 5 minus x squared. So we know we want to do this because you always want to get the denominator looking nice. So this would tell us that du is equal to minus 2x dx, which is pretty close to what we have up there. So we have 6 over 5. Well, we see that x dx is equal to minus 1 over 2 du. 1 over 2 du. And then on the bottom we just have u. So this is 1 over 5 ln absolute value of x. I forgot that. Don't forget the absolute value of x. Minus, I have a 6 and a 2 here. Sorry, I should do this in red. So this gives me a minus 3 over 5. And then I have integral 1 over u du, which I know that's ln absolute value of u. So this is 1/5 ln absolute value of x minus 3/5 ln absolute value of 5 minus x squared. Which I can rewrite if I wanted. Sometimes they like this to be done. not necessary, minus 3/5 ln 5 minus x squared. Well, I can write this as ln absolute value x to the 1/5 minus ln absolute value of 5 minus x squared to the 3/5, which is equal to ln of everything here. We have x to the 1/5 over 5 minus x squared to the 3/5. And then this is our answer.